everybody. Today we are solving rational equations. And we're going to also look for extraneous solutions. So, what exactly is a rational equation? It's an equation that contains a rational expression. So, the things that we've been working with multiplying, dividing, adding, subtracting, simplifying, those are rational expressions. So, we'll be solving equations. We'll be figuring out what x is. So, we're going to identify the domain, solve the variable. So first, to solve, you're going to identify the domain first. So that's what we'll do first. And then we're going to multiply both sides of the equation by a common denominator. Then we're going to solve. The step 2, the multiply both sides by a common denominator, what that does is it should eliminate any fractions. And when we eliminate the fractions, it makes the equation look a little more friendly and nicer to solve. Next, then we'll check for extraneous solutions is not valid because that value would be excluded from the domain. So here's what I'm talking about. Let me show you what I'm talking about. So algebraically, if we look at this example on the left first, the equation would be 1 over x plus 2 over x equals 1 over 6. So here I look at this equation and I notice that if x were to be 0, then I would be dividing by 0. So that's why right here it says the domain cannot be 0, because if x was 0, then I would be dividing by 0, and we have an issue with the domain there. Then we would look at the denominators. We would identify the least common denominator, get a common denominator, multiply both sides. So in this case, the common denominator looks like it would be 6x. Because it's 6 and an x, so the least common multiple of those is 6x. Multiply both sides of the equation by the 6x. When you distribute that 6x here, you'll have 6 plus 12. And then just multiply that out. 6x over 6 simplifies to x. And look, all the fractions get eliminated. We eliminated fractions here. Oh, I can't spell. Eliminated the fractions. We'll just say that I said that. Eliminated fractions. Then we solved and got 18. Now notice 18 was not excluded from the domain. So 18 was included in the domain. So the solution to this equation is 18. So that's what we'll be doing here. And if you want to glance at what's happening in the second example, then this is what we're doing today, what that's going to look like. So let's work out a couple of these. Example 1, what's the solution to the rational equation 2 over x plus 5 equals 4? So remember, the first thing we want to do is identify the domain for the variable. So step 1, what's the domain? Remember, we have an issue with the domain if we have to divide by 0. So I look at this, and I notice that if x were negative 5, my denominator would be equal to 0. So x is not allowed to be negative 5. Okay, step 2, multiply both sides of the equation by a common denominator. So a common denominator here looks like it's going to be x plus 5. So 2 multiply by the common denominator. So I'm going to multiply both sides by x plus 5, multiply that on the left by x plus 5. So on the left side, the x plus 5's divide out because x plus 5 divided by x plus 5 is 1. So the left side, I'm just left with 2. On the right side, if I distribute the 4, I'll have 4x plus 20. And look, no more fractions. They're all gone. I just made this equation look a lot simpler. So then if I subtract 20 on both sides, I'll have negative 18 equals 4x. So if I divide both sides by 4, negative 18 over 4 equals x. So x looks like it is negative 9 over 2. And negative 9/2, is that one? Is it okay for x to be negative 9/2? Yes, it is, because x can be anything except negative 5. So this is a good solution. It's not extraneous. So on the second one, I can work it out very similarly. Let's see, I look in the domain. So the domain, I need to think, okay, what would x be that would cause this denominator to be 0? X is not allowed to be positive 7, because if x were 7, 7 minus 7 would be 0. Then I would be dividing by 0. So x is not allowed to be 0. Okay, now I'm going to find the common denominator. Common denominator looks like would be x minus 7. So I'm going to multiply both sides by x minus 7. So multiply on the right, multiply on the left. So when I multiply on the left, the x minus 7's divide out, and I'm left with the 1. On the right, if I distribute that 2, I'll have 2x minus 14. No more fractions. Add 14 to both sides. 15 equals 2x. So x is now 15 over 2. Now we'll do our word problems next class. So let's skip ahead to example 3. Here I have the equation 1 over x plus 2 plus 1 over x minus 2 plus 4 over x plus 2 minus 2. So the equations get a little more complex as we go through. So, but the steps are going to remain the same. So I still want to think about what my domain is. I look and see, okay, x for the first fraction, x cannot be negative 2. And then second fraction, if x were positive 2, 2 minus 2 would be 0. Well, let's just do a comma. X cannot be negative 2 or 2. And then right here, it looks like I've handled it. Okay, second, the common denominator, or the LCM, I see an x plus 2. I see an x minus 2. And then x plus 2, x minus 2. So it looks like this is the least common multiple, x plus 2, x minus 2. So I'm going to multiply both sides of my fraction, or both sides of the equation, by x plus 2, x minus 2. All right, so I am going to write all of this out this first time, and then we'll kind of see how we can make our process a little shorter. So on the left side, the x plus 2, x minus 2 actually needs to distribute to both parts because there's a sum inside of that parentheses. So the first fraction is now x plus 2, x minus 2 over x plus 2. Plus, when I distribute this product to the second fraction, I now have x plus 2, x minus 2 over x minus 2. And on the right, if I distribute, well, not distribute because it's not, there's only one term in the numerator, I'll have 4 times x plus 2, x minus 2, all over x plus 2, x minus 2. So now I look and say, okay, well, I'm supposed to have all the fractions being, these fractions are supposed to have been eliminated at this point. So let's see what happens. In the first fraction, the x plus 2's divide out, and I'm left with x minus 2. The second fraction, the x minus 2's divide out, I'm left with x plus 2. The third fraction, the x plus 2's divide out, the x minus 2's divide out, and I'm left with 4. Hey, no more fractions. So now I'll solve. X plus x is 2x. Negative 2 plus 2 is 0 equals 4. So x, 4 divided by 2 is 2. So I get that x equals 2. I'm going to circle it. But hang on. Early in the problem, we said that x is not allowed to be negative 2 or 2. So that means x can't be 2, this is an extraneous solution. So that means since x equals 2 is extraneous and there's no other x's to choose from, this problem has no solution. So I can either write no solution, or I can use this symbol for the empty set. That also means no solution. Now let's look at example 4. It looks really similar. So we're still going to follow the same steps. It's just going to get a little more complicated on this one, but it's still not too bad. So I look, first of all, I'm going to identify my domain first. That's really, really important and helpful at the end. Let's see. The first term, x, is not a fraction. It's actually x over 1. So there's no issues with the domain for this fraction. But the second fraction, it's over x minus 3. X would not be allowed to be 3 because if x were 3, then I would be dividing by 0. So x can't be 3. And the same for the last fraction. X can't be 3. So the domain for this whole equation, x cannot be 3. Now, let's multiply everything by the least common multiple for the denominators. Oh my goodness. LMM, the LCM for the denominators. So I look, I see, okay, first denominator, x minus 3 looks like my denominator is going to be x minus 3. So I'm going to multiply both sides by x minus 3. The x minus 3 on the left does need to distribute to both parts. So it looks like I'll have this x times x minus 3 plus 6 times x minus 3 over x minus 3 equals 2x times x minus 3 over x minus 3. Now, hopefully, after I get through dividing everything out, I won't have any fractions anymore. The first part, let's see, the x, I can't cancel anything out or divide anything out on the first term, but I can distribute this x so that I have x squared minus 3x plus the second fraction, the x minus 3's divide out, and I'm left with a 6 equals. The x minus 3's divide out again, I'm left with 2x. So now I have the equation x squared minus 3x plus 6 equals 2x. And I notice that there is a squared here. Oh, since there is an x squared, that means that this is a quadratic equation. Quadratic equation, since I have an x squared. So it means I'm going to try to use my quadratic equation solving methods like factoring or quadratic formula. Let's try factoring first. I need to set it equal to 0, so I'm going to subtract the 2x on both sides. X squared minus 5x plus 6 equals 0. Now I will factor. Looks like I could do a minus 3 and a minus 2. So then x minus 3 equals 0. X minus 2 equals 0. X would be 3 and x would be 2. But then I got to be like, wait a minute, hold on. Earlier I said x is not allowed to be negative 3, or sorry, not allowed to be 3. So that means this first answer is extraneous. There's only one solution to this problem, x equals 2. And then the last one, I look at, maybe is it the last one? Yes, it's the last one. Okay, so I look at this, domain, x is not allowed to be negative 5 would cause the domain to be, or denominator to be 0. So x cannot be negative 5. So now I multiply both sides by x plus 5. Boom. Oh, look, makes everything divide out. And I'm just left with x squared equals 25. Ooh, so simple. Take the square root of both sides. Remember, I'm solving for what x could be. So the square root of 25 is 5. So x could be positive 5 or negative 5, because 5 times 5 would be 25. Negative 5 squared is also 25. So I've got two solutions, don't I? No, I don't. X can't be negative 5 because we excluded it from the domain. So if I were to say, let's do this. Let's write it out like this. From the equation that I solved, x can't be -5 because that would be extraneous. X has to be +5.